Hello, welcome to another module in this massive open online course. So, in this module we will look at a different topic, that is frequency translation or frequency mixing. Okay. So, we will start our discussion on a new topic, that is frequency translation in a communication system or frequency mixing. Frequency translation or frequency mixing, frequency translation and mixing in communication systems. In communication systems. Now, this frequency translation, all right, it's a very important idea, or frequency shifting through mixing is a very important idea in signal processing at the receiver in a communication system, in which all the signals at the different carrier frequencies, like all the various signals that can be received, right, at the receiver, are shifted or translated to a common frequency. Okay. So, this in the processing of signals, in communication system, it is desirable to shift or translate the modulated signals at the receiver to a new center frequency. So, in or for signal processing and communication systems, for signal processing in communication systems, it is desirable all the modulated signals or translate all the modulated signals to a new center frequency, to shift all the modulated signals to a new center frequency, either shift, or basically this can also be seen as translate. Translation is nothing but shifting. So, we would like to shift or translate all the modulated signals, received modulated signals, to a new frequency. All right. This operation is termed as, now this operation is termed as, so this is termed as frequency mixing or heterodyning. This operation is termed as frequency mixing or heterodyne or heterodyning. Okay, this operation is termed frequency mixing, or the receiver, this is termed as a heterodyne receiver, all right, which performs this heterodyning operation. All right, and this new center frequency, all right, this new center frequency, this common center frequency to which all the received center signals are translated, this is termed as the intermediate frequency, IF. This new center frequency, this is termed as the intermediate frequency, this is termed as the intermediate frequency or IF. Okay. After this, the signal is amplified, filtered and demodulated. After this, amplified, filtered and after this the filter is after this the signal is amplified, filtered and demodulated. Okay. So, this is termed as the intermediate. So, all the frequencies, the modulated signals are translated to a common center frequency and U center frequency, which is termed as the intermediate frequency. This process called as frequency translation or mixing or basically heterodyning. Okay. This is done in a heterodyne receiver. Okay. Now, for instance let us take an example. All the amplitude model, all AM radio signals, all the amplitude modulated radio signal all the AM radio signals, that is in the 540 to 1600 kilohertz, but there is all the radio signals at these different characteristics in the different center carrier frequencies in this band are shifted to the common frequency, shifted or translated to the common intermediate frequency equal to 455 kilohertz. This is your intermediate IF for basically the intermediate frequency. Okay. This is your IF for intermediate frequency. And how is this achieved? This is achieved as follows. For instance, let us say I have xt, which is the incoming message signal, incoming signal, modulated signal, nt cosine 2 pi f1 t. So, this is the incoming signal. Okay. So, this is your incoming signal. Now, what I am going to do? I am going to mix this, I am going to demodulate. This operation is known as, this process is known as mixing. Mixing is nothing but demodulating, but with a different frequency. So, you are mixing it with a different frequency, that is the whole idea. So, I am demodulating this with a different frequency, I am mixing this. So, this is a local oscillator. Now, in a coherent demodulator, we demodulate with the same frequency. If f1 is the frequency, carrier frequency of the incoming signal, we demodulate with f1. But here we use a different frequency f2, all right, demodulating or mixing with this frequency, multiplying with this frequency carrier of frequency f2. Okay. So, I have this local oscillator which generates this carrier at 2 cosine 2 pi, not f2 but f1 plus f2t. Okay. So, mixing with, so this local oscillator basically corresponds to frequency. So, the local oscillator corresponds to frequency f1 plus f2. This basically is a mixer. Okay. This is basically what it is doing, is performing a mixing operation. Mixer basically is mixing, there is an incoming signal frequency f1, signal local oscillator frequency f1 plus f2. So, this demodulate is basically, this mixer is mixing these two signals and we get an output. Now, what is the output that we get? So, let us call this output x tilde t. Now, let us examine this output x tilde t. X tilde t equals, this is equal to mt cosine 2 pi f1 t times, that is your xt times cosine 2 pi f1 plus f2 t, that is the carrier frequency of the mixer, that gives me half mt cosine 2 pi f1 t into cosine 2 pi f1 plus f2 into f2 t, that is, so this is half cosine 2 pi f1 plus f2 minus f1 f2 t plus cosine 2 pi f1 plus f2, that is 2 f1, that is basically your 2 f1 plus f2 t. Now, this is at a much higher frequency, though this can be eliminated by band pass filtering, that is band pass filtering at f2. This 2 f1 plus f2 can be eliminated by band pass filtering at center frequency f2. Therefore, what we have to do is at the output we have to pass it through a band pass filter centered at f2, and once you pass it through a band pass filter centered at f2, this component gets eliminated. What we get after BPF, is half mt into cosine 2 pi f2 t. So, now you can see it is translated to this new frequency f2, where f2 is the intermediate frequency. So, this f2 is nothing but if, that is the intermediate frequency. So, this is translated to the intermediate frequency f2. Translated to the intermediate frequency f2, and therefore, the output of this will be half mt cosine 2 pi f2 t. This is your IF signal, intermediate frequency signal. Okay. So, basically what we are doing is we have this f1 incoming signal carrier frequency f1 mixing with, we are mixing with the locally generated carrier which has frequency f1 plus f2, and therefore, after you band pass filter the output, you get the net signal with at the intermediate frequency, that is mt half mt cosine 2 pi f2 t, which is at the intermediate frequency IF f2. So, this is the IF stage. So, basically this is your intermediate frequency stage. In this IF stage, the signal is automatic, suitably, as we said in the IF stage, signal is amplified, filtered and then demodulated. So, in the IF stage, signal is suitably amplified. So, we first amplify, we filter, and we demodulate. Demodulate in the sense multiply by f2, carrier frequency f2. Remember, now the IF stage has frequency, carrier frequency f2 because it is cosine 2 pi f2 t. So, you multiply by cosine 2 pi f2 t followed by low pass filtering. Okay, that is again the followed by and then LPF, which gives you your MT basically. Okay. So, that is what we are doing. Okay. So, that basically describes this property of translation or mixing, where what we have seen is basically we have incoming signal carrier frequency f1, all such, so various possible different carrier frequencies, signals of various possible carrier frequencies are translated to a common intermediate frequency, that is f2. This operation is known as translation, alright, frequency translation or basically heterodyning. okay, and this now the incoming signal can have a different frequency f1, all right. Therefore, the mixing frequency f1 plus f2 is also going to change. However, the f2, that is the frequency of the intermediate frequencies, this is going to remain constant, all right. This IF, the intermediate frequency f2 is always constant, all right. So, all the frequency, all the signals, modulated signals irrespective of f1 are mixed by f1 plus f2 to bring them or to translate them to a common intermediate frequency f2, all right, all right. So, this is the operation in a heterodyne receiver, all right. So, we will stop here and continue with this in the subsequent module. Thank you.